Welcome viewers, in this video we will see the torque equation of induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the topic, torque equation of induction motor. The torque produced in induction motor is depends upon the following three parameters. So the torque equation also based on these three parameters. So we need to analyze these three parameters. First one, flux required to produce the EMF, electromagnetic force. So first one is the flux. What is the flux available? Next one, rotor current. It is called as I2R. I2R refers the rotor current. Then power factor of rotor circuit at running condition, that is cos pi 2R. 2R refers the rotor. So this torque is depends upon flux requirement, rotor current, power factor of the rotor circuit under running condition. So by combining three, we can write it as torque is directly proportional to pi I2R into cos pi 2R. Depends upon these three parameters. Now we need to see find the expression for pi, rotor current I2R and power factor cos pi 2R, so that we can finalize the equation for torque. Now take it, this is the equation number 1. Now first we will analyze the flux produced. The flux produced in the stator is depends upon the stator applied voltage. So the pi is directly proportional to E1. Depends upon the voltage applied, the flux is produced. So the pi is directly proportional to E1. At the standstill mean that is at the rest condition, we know that E2 by E1 equal to N2 by N1, that is equal to K, transformation ratio. It is very similar to the transformer. We are treating as stator and rotor as primary winding and secondary winding. So E2 by E1 equal to N2 by N1 equal to K. I will take this E2, then EMF in the rotor, E2 by E1 equal to K. So that E1 is directly proportional to pi. So that the E1 is replaced by pi, that is equal to K, right? So the E1 is directly proportional to pi, so that E1 is replaced by pi. So by cross multiplying this, what we got? E2 equal to K into pi. This pi is multiplied here, E2 is K into pi. That is E2 is directly proportional to pi. Already we discussed E1, the pi is directly proportional to E1 and this pi also directly proportional to E2. Now we got the expression for the flux. Flux is depends upon E2. Initially it is based on E1. Based on the transformation ratio, by substituting what we got, the flux is also proportional to E2. Then we will go to the rotor current and rotor power factor. I2R. I2R is nothing but E2R divided by Z2R. EMF divided by the impedance. Right? This E2R is nothing but S into E2 divided by Z2R is square root of R2 square plus S into X2 square. Rotor resistance and reactance. This formula already available. Right? So E2R is S into E2. This S is nothing but the slip of the induction motor. And Z is nothing but square root of R2 square plus Sx into X2 square. You take this equation number 3. Then the power factor, rotor power factor cos pi 2R is nothing but R2 by Z2R. So this general formula is available. Power factor equal to R by Z, resistance by impedance. Based on that, we have R2 by Z2R. So that is equal to R2 divided by Z2R is nothing but R3 square plus S into X2 square into S into X to the whole square. Right? So we take this equation number 4. Now we got the expression for flux or rotor current and rotor power factor. Now we will substitute this equation 2, 3 and 4 in the equation 1, so that we can able to frame the equation for torque. So while substituting, the T is directly proportional to E2, pi. Pi is nothing but E2. This is the rotor current. S into E2 divided by square root of R2 square plus S into X2 square into this power factor R2 divided by square root of R2 square into S into X2 square. So this is available 2 times, 2 square is available, square root. So that it become easy, it become the normal term. So the E2 available 2 times, S is available. So S into E2 square into R2. This term available 2 times, so it become, while taking the square root available 2 times, so it become r2 square plus s into x2 square. So that can be written as the while equating we need to introduce the constant k into, so that t equal to the equation for torque t equal to k into s e2 square r2 divided by r2 square plus s into x2 square. So we got the equation for the torque. Now we'll see what is the k. What is k is nothing but constant of proportionality. While equating any proportionality we need to introduce the constant. So that the constant value is nothing but 3 divided by 2 pi ns. This ns is nothing but a synchronous speed in rps, n divided by 60, ns divided by 60, right. So the k is nothing but 3 divided by, for 3-phase induction motor, 3 divided by 2 pi ns. Ns is nothing but a synchronous speed, that is nothing but ns divided by 60. So if we substitute the k value, we will get the final expression for the torque t equal to 3 divided by 2 pi ns. This k is replaced. This k is replaced by this value. S e2 square r2 divided by r2 square plus s into x to the whole square. The unit is Newton meter. So this is the equation for torque developed under the running condition. So now we got the expression for torque. Now we'll go to the equation for the starting torque. This is the normal torque under the running condition. So at the starting torque, we will analyze now what is the starting torque of the induction motor. So at the starting or instant of starting, n equal to 0. The speed is 0. So the slip s is nothing but ns minus n divided by ns. So this is the definition of the slip. So in this now n is equal to 0. N equal to 0. There is no current. There is no speed at the standstill at the starting. So this equation become ns by n. This n is 0. So ns by n got cancelled. So s equal to 1. So at the starting the speed is 0. The speed is substituted in the slip. So we got the slip equal to 1. So in the normal torque equation is available here. The torque equation is there. In that this s equal to 1 at the starting condition. At the starting s equal to 1. So if we substitute s equal to 1, we will get the expression for starting torque. In this equation we need to substitute s equal to 1. So while substituting, what will happen? This torque becomes starting torque. 3 divided by 2 pi ns, this s is 1, right. E2 into R2 divided by R2 square plus here one s will be there, that also 1. So x2 square. So this is the expression for starting torque. This s is now replaced by the 1. Now we will see the maximum condition for maximum torque under the running condition. What is the condition for maximum torque? In order to get the maximum torque, the equation is, the condition is differentiation of torque equation with respect to slip equal to 0. D by dt of the torque equation t equal to 0, right. We are going to differentiate the torque equation with respect to s, and if you put the by equating into 0, we will get the maximum condition. So that this is normal mathematical. In mathematics also you already studied, right. Differentiation of the term while equating 0 will get the maximum value. So here we are considering the slip. Why? The slip is variable in the torque equation, right. The torque equation, the slip is keep on changes, variable 1. So we need to differentiate with respect to the variable parameter. Here the slip is the variable parameter, right. So that we are taking slip as we are differentiating with respect to the slip. So the normal torque equation is k into s e2 square r2 divided by r2 square plus s into x to the whole square, right. So this we will go for a square this time, so that t equal to k into s e2 square r2 divided by r2 square into s square x2 square, so that it is easy for going for a differentiation. Now we need to differentiate this equation, d by ds of t equal to 0, right. So this is a torque equation available. So d by ds, differentiation with respect to slip, into the torque equation. Now substitute this torque equation here, k into s e2 square r2 divided by r2 square plus s2 square x2 square, that is equal to 0. So by differentiating this equation with respect to s, equating the 0, we will get the condition for maximum torque. So we need to differentiate this expression. See, we are differentiating with respect to s, slip. The s is available in the numerator as well as the denominator, right? So the numerator and denominator available, so we can go with the u by v method. Differentiation u by v method, right? Differentiate the is a division. So u by v method, what is the formula? V u dash minus u v dash divided by v square, right? So this is nothing but u. This term is nothing but u. This term is nothing but v. The numerator is u, denominator is v. So based on the formula v u dash minus u v dash divided by v square, the v. First we will write the v. So this is nothing but your v. Denominator is the v. So it is written as it is, r2 square plus s2 square into x2 square into u dash. What is u dash? You have to differentiate this term. U is this value, u dash means differentiate. So while differentiating, s is available. So the differentiation of s is 1. So that we got k e2 square into r2, right? So this is u, denominator value. This is u, numerator value. U dash mean numerator value is differentiated, while differentiating s equal to 1 minus u. You have to write this u as it is, k s e2 square into r2 divided into v square, v dash. What is v dash? V is nothing but denominator. You have to differentiate this term. R2 square is, this is constant, so it become 0, right? This differentiation of s square is 2s into x2 square, right? So this is nothing but v dash. V is this value, v dash mean differentiate. While differentiating, this is become 0. This differentiation of s square is 2s and x2 square divided by v square. This v is available, you have to write it as v square, right? Now we differentiated this equation. V u dash minus u v dash divided by v square. So this is u, this is v. So after differentiation, while cross multiplying this term become 0, right? So only we got this r2 square into s square into x2 square into k e square r2 minus this entire term 2 k s square e2 square r2 into x2 square, that is equal to 0. Now we will multiply this term. There are two terms are available, so we can go for further simplification. So while multiplying here, k r2 square e cube plus, here already one e is there, so it become e cube plus k s square e2 r2 into x2 square minus this term 2 k s square e2 square r2 into x2, right? So this term available 2 times, is available 2 times. So 1 minus 2 means minus 1, right? This will take, this is 1, this is minus 2, 1 minus 2 is 1, minus 1. So that k r2 square into e square minus this k s square e2 square r2 into x2 equal to 0. So while multiplying this, this r2 is cube value, this e is only square, right? K r2 cube, here because here r2 square is available, here r2 is available, so r2 cube, then e2 square into this value, right? Only the small correction is there, here r2 cube e2. So again, so this value available 2 times, this is similar value, so 1 minus 2 is minus 1. Now we can take these terms commonly, k r2 square r2 into e2 square, these values are available commonly, k available here and here also, here r cube is available, here r2 is available, here e2 square available, here also e2 square available. So we will take the k r2 e2 square outside. So what will happen here? We have r2 square minus s square into x2 square, right? The k taken outside, s2 square is available here, e2 square is taken outside, r2 also taken outside, only we have x2 square available here, right? So this term while equating, what will happen? This term automatically 0. only we have R2 square minus S square x2 square equal to 0. Bring this term in the right hand side. So that R2 square equal to S square into x2 square. So this is R2 square. R2 square equal to S square into x2 square. Now we'll go for further simplification. So that this S square equal to R2 square divided by x2 square. So finally what we need is we need a condition for maximum torque so that it is expressed in terms of the slip. So while S square, while taking square root on both the side, S square become S, this term become plus or minus R2 by x2. So both the possibilities are available, plus as well as minus. Now we are neglecting the negative value, only we consider positive value. So that S equal to R2 divided by x2. So this is nothing but the value of the slip at the maximum torque. The value of the slip at the maximum torque is R2 by x2. So from that we can write the condition for maximum torque. What is the condition for maximum torque? Sm equal to R2 by x2. The slip should be equal to R2 by x2. So this is the condition for maximum torque. Now we will find the magnitude of this maximum torque. What is the this is the condition we calculated. Now we will find what is the magnitude of the maximum torque. So the maximum torque is obtained at Sm equal to R2 by x2. So in the torque equation, if you put S equal to Sm equal to R2 by x2, we will get the maximum, the expression for magnitude, maximum magnitude of the maximum torque, right. So in the normal torque equation is available, T equal to K into S E2 square R2 divided by R2 square plus S E2 square in E2 square. So in this S is replaced by Sm, that is equal to R2 by x2. So that we will get the maximum torque, right. So substitute S equal to Sm, that is equal to R2 by x2. So at the while substituting, the torque automatically become maximum torque, that is equal to K Sm. S is now replaced by Sm. E2 square R2 divided by R2 square into Sm square into x2 square. S become Sm square. Now we can substitute the Sm value. Sm value is nothing but R2 by x2. Here R2 square divided by x2 square. This x2 got cancelled. Now we will go for further simplification. So after simplification we got K E2 square R2 divided by this, take the x2 outside, so that R2 square into plus 2 R2 square. So this available 2 times. So K E2 square R2 square divided by x2 square into 2 R2 square. Here the 2 is not available. R2 square plus R2 square, right. So R2 square plus R2 square become 2 R2 square. So this R2 square got cancelled. So finally what we got? T maximum, the expression for the magnitude of maximum torque is K E2 square divided by 2 into x2, right. Now we can substitute this value in the torque equation, so that we will get this T max equal to K E2 square divided by 2x2. This K is nothing but 3 divided by 2 pi ns, based on the 3-phase induction motor, into E2 square divided by 2x2. So this is the equation for the magnitude of the maximum torque, right. By using the condition Sm equal to R2 by x2, by substituting we got the expression for the magnitude of maximum torque. Now we will see the condition for maximum starting torque. We already discussed the maximum torque, now it is a maximum starting torque. So at the starting, the slip equal to 1, we already discussed slip equal to 1, that is Sm equal to 1. For a condition Sm equal to R2 by x2. If Sm equal to 1, what will happen? R2 by x2 equal to 1. So that R2 equal to x2. So the condition for maximum starting torque is R2 is equal to x2. The resistance of rotor and reactance of the rotor should be equal, right. So this condition we are getting by substituting S equal to 1, because at the starting slip equal to 1. By substituting this value in the condition, we got R2 equal to x2. Now we will see the starting torque of a squirrel gauge rotor. What we discussed so far is split ring. This is squirrel gauge. In case of squirrel gauge, the resistance of squirrel gauge rotor is small, than reactance. The resistance is very less compared to the reactance and is also almost constant. Starting current I2 is of very high magnitude and lag behind the E2 by an angle of large angle, right? So the starting current is very high. So the starting torque is very poor because of current is lagging the voltage E2 at a very large angle. So the starting torque is very less. So that it is not used for motor which is used to start the heavy load. In case of the motor started with the heavy load, we are not using this squirrel gauge rotor. Squirrel gauge rotor used for only the medium load or less loaded. For heavily loaded, it is not used. So in this video, we discuss about the torque equation and condition for maximum torque, condition for maximum starting torque, and magnitude of the starting torque and starting torque of the squirrel gauge rotor. These things are discussed in the video. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.